Number 12, there's a number of ways we can tackle this one. We have this unknown positive constant k. We know the greatest solution to this equation is 12, and what is the value of k? So there's a lot of options here. Remember, as a constant, k has some specific value that we're trying to find. So I cannot plug in for k here. I can't say, well, let's assume k is 3, because the whole point is to figure out what the value of k is. But we do know that the greatest solution to this equation is 12. So we might think about plugging 12 in for x and then solving for k. That might not be a bad idea. So we're going to get we'll try it this way first. Square root of 5 times 12 minus k is equal to 12 minus k. Because again, if 12 is a solution, it means when I plug it in, it should satisfy this equation. And now I've got an equation in terms of one variable, which is good. So let's go ahead and square both sides. 5 times 12 minus k, the square root is canceled by the square on the right side. And here I've got to FOIL this. There is maybe a shortcut where I wouldn't have to FOIL this, but we'll do it this way first. So we'll go ahead and FOIL this out because it's just 12 minus k times 12 minus k. So we have to bring in that middle term. And this is going to be, let me actually just expand this. This will be 60 minus 5k. And let's bring everything over to the right side, I guess. So I'm going to get k squared minus 19k plus 84 is equal to 0. So now we can factor two numbers that multiply to 84 and add up to negative 19. So that will be 12 or negative 12 and negative 7, because negative 12 times negative 7 is 84, and negative 12 plus negative 7 is negative 19. So we get here two values for k, and these are both legitimate values for what we've done so far, but we obviously run into a problem here, which is they want to know the value of k, and they didn't ask for what is a possible value of k. So there has to be some way of distinguishing which of these is the correct answer. Now, you might look at the 12 here and say, oh, maybe it's 12 because of this 12 here. Maybe, but it won't be because of this, right? This 12 is, as we saw before, the solution. It's what x equals. So it doesn't necessarily mean k will be 12 too. So how are we going to make this determination? One option here would be, now that we have values for k, let's graph these functions in Desmos and see what we learn. So let's try k equals 12 first, plugging that in. Let's see if we'll do it this way. 5 times x minus 12 equals, I might split it up, because sometimes when we graph it like this, we get kind of a weird result. Yeah, let me just separate these. I'm going to separate these out. That's one option. So I'm going to put the left side as one line. I'm going to put the right side as another line. And also what we're looking for here are the solutions to this system. Like another option, maybe you'd prefer this if you want to keep it all in one line, is let's just bring this over to the other side and set it equal to 0. So we're going to get minus, I'll put this in parentheses, x minus 12. And then we want to know, again, where the solutions are, where this equals 0. Okay, so we get this graph, and we see two solutions. And this is the problem with this answer. This is why k will not be 12, because there is this constraint. The greatest solution is 12. And in this case, when we make k equal to 12, we see there's two solutions. There's 12 and 17. But in this scenario, this can't work because they said the greatest solution is 12. So that's why 12 is not going to be the answer. Let's try 7. So I'm just going to swap in 7 for k here. So we do also get two solutions. And again, 7, there must be some connection here, as it turns out, between k and x, which might be interesting to explore. But the point is, this also has two solutions, but the greatest solution here is 12. And that's going to confirm for us that 7 is indeed the answer. And I think there's a more direct way to do this, which doesn't require that kind of plugging in. I mean, it definitely works. We can use Desmos, but there's still a lot of little fiddly bits to it. So I would like to see, is there a faster way we can do this? And I do think that there is. Let's begin. We're not going to plug in for k this time. Let's go ahead and square both sides. And in fact, I'm going to move this over here as well. So I'm going to get x minus k squared. I'm going to leave that alone for now. And this is what I was referencing before. I said earlier in the solution that when we did this step, we technically didn't really need to FOIL out the 12 minus k, but we'll show you why here. We're going to leave the x minus k squared. And then I'm going to get minus, and then the square cancels out the square root just like it did on the last step. So we get this. Now here's the move. The move is going to be, yeah, I could FOIL this out and combine like terms, but I don't think I'm going to be able to factor it because of the presence of the k. Let's actually factor out this common factor of x minus k from both of these terms. So x minus k, and then what am I left with? I'll be left with x minus k minus 5 when I pull the x minus k out of each of these terms. This is equal to 0. So let's set each of these equal to 0. And actually, I said before that the 12 being 12 for both k and x was a coincidence. It actually isn't now that we unpack this math a little bit more. And that's why when we also plugged in k as 7, we got a solution of 7, because we see, indeed, one of the solutions is x equals k. What's the other solution? Well, I'm going to set x minus k minus 5 equal to 0. So x would equal k plus 5 in this case. Now, a couple items. We know that k is a positive constant, so we know that k is going to have to be less than k plus 5, right? That this solution of k is smaller than k plus 5. But we know that the greatest solution, which is going to be k plus 5, the greatest solution must equal 12. So this is the greater of the solutions, so I can set my k plus 5 equal to 12. And here we go. Here's the proof that k is equal to 7. So either way, you'll get 7.